In this lesson, we are going to learn how to solve systems of equations by substitution. You will notice that I have my first equation not in any form that we would recognize, it just has x by itself, and my second equation is in standard form. The goal for substitution is to get a variable by itself. If you remember back in middle school, you would have an equation like 3x equals 6, and then they tell you x equals 2. So you'd substitute in that 2 and check that it worked out. Or they maybe would have you say, what is 3xy? And then in the key they'd say x equals 2, y equals 3. And you'd have to then go in and substitute that 2 in the x spot and that 3 in the y spot. So then you'd have 3 times 2 times 3. And you'd find out your answer is 6, so 18. And you'd go through and simplify expressions like that. That's basically what we're doing, except we're going to have a little bit more work with variables involved. So if you look at our equation, you'll want to first step in substitution is you're going to want to make sure that one of your equations has either an x equals or a y equals. We have that here. Instead of it saying x equals 3, it's saying x equals negative 2 minus 3y. So I'm still going to substitute that into this equation for x because it's what x equals. If you remember this from Algebra 1, I often have my students actually draw the circle and arrow. You don't have to do that now, but that's still the same thing that applies. We're substituting that value in for the x. So I would take my second equation and I copy everything the exact same, except where the x is, I would write negative 2 minus 3y. I still bring down the minus 3y equals 5 from that equation. So take a look at my second equation in your problem and what I just wrote. The only difference is that where the x is, I put the circled value because that's what x equals. From here, then, it's just a regular algebra problem. So I'm going to go ahead and distribute the 2. And I would have negative 4 minus 6y minus 3y equals 5. I would combine like terms on my left side, so I have negative 4 minus 9y equals 5. Then we just continue to solve for y. Negative 9y equals 9. Divide by negative 9. And I find y to equal negative 1. Now we are still, just like with the graphing method, we are looking for where these lines intersect. So we are still looking for an ordered pair as our answer. Now that I have y equals negative 1, I'm going to take my circled equation, so the whole thing, and where the y is, I will substitute negative 1. So I'll copy it the exact same, except where that y is, I'll put a negative 1. And then I solve for x. So x would equal negative 2 plus 3. So x equals 1. You actually can substitute into either of the equations. It doesn't matter which one of these two equations you pick. I just think it's easier to pick the circled equation, but it does not matter. The y will substitute into both, and you'll get the same answer for x. So my answer for number 2 would be 1, negative 1. And again, what we're actually finding here is where these two lines have a commonality. This is their intersection point. So when we start talking about actual values for variables, we'll see where things are common, and that's what we'll be looking for, is that intersection point where they meet. So my answer is 1, negative 1. The second problem that we're going to do, you'll see, is two equations in standard form. So I'm going to want to get one of my equations to have x or y by itself. There's 4 choices, right? I could really choose this first x, this first y, this x, or this y. I want to pick a variable that doesn't have a coefficient. I don't have to do that. All of them work. But I want to pick one that doesn't have a coefficient, so that would be either this x or this negative y, because then I don't have the chance of dividing by something and getting fractions. And I can do fractions, but it's going to be quicker for me if I just deal with integers. And so my best choice is a positive 1x or 1y. Either of the circled variables would be great choices. My best choice is the x, because to get this x by itself, all I have to do is subtract 3y. So as I come down, I have x equals negative 3y minus 6. That's replacing this equation. So please don't try to substitute it back into itself, because that will totally change your answer because it's the same line. I'm going to cross that one out lightly so I know that I'm not working with that. So now I'm going to take what x equals, and again I'm going to substitute that in for x in my other equation. So I have the 2x minus y equals 9. I'm not going to change anything in that equation. I'm going to have a 2, except where the x is, I will substitute that value for it, negative 3y minus 6. Then everything else stays the same. So again, take a look at that top equation and look that I've changed nothing in it except where the x is. I've substituted negative 3y minus 6. So now I would distribute here, and I'd get negative 6y minus 12 minus y equals 9. I would combine like terms on my left side, so I'd have negative 7y minus 12 equals 9. I go ahead and add 12 to both sides. So negative 7y equals 21. Divide both sides by negative 7, and I find y to be negative 3. Then, to find x, I can go ahead and take this y value I just got and substitute it into this spot right here. So if I copy that equation the exact same, except where the y is, I would substitute negative 3. I end up with 9 minus 6. So I find x to be 3. So my answer, remember you always list your x value first, would be 3, negative 3. This is where these two lines intersect, at the ordered pair 3, negative 3. Both of our examples for this, you'll notice that we solve for x. Just so you know, it is okay to solve for y also. You can have it say y equals at the start. So I'm talking right here. When I got x by itself. If you had y by itself, you would do the same process, just replacing it for y.